The class is in recording. Yes, term to describe spherical mirrors. Yes, very good, Samriddhi. Good job. Hmm. Okay, hold on a second. Yeah, all right. Let me put this is where we were, and there we go. Okay, so important terms used to in the study of spherical mirrors. We have done this one, right? Center of curvature, radius of curvature, pole, principal axis, principal focus, focal length. Everybody remembers them, right? You have to memorize them. These are very important terms, and let's be very clear, like you should be able to recall the each and every term at your fingertips, है ना? It should be that clear. If you have this much clear, the rest of the chapter and actually rest of the entire physics is very easy, right? So let's go ahead. Center of curvature, we have discussed this one already, right? Okay. Now, if I put these 2 points, we know that a concave lens or a spherical lens is basically a part of a big sphere, है ना? Right? That we have done. Center of curvature is the what is the center of curvature? It is the center of the actual sphere of which the lens is part of, है ना? Right? So we have got that much. But when we talk about the spherical lenses, we will focus on this tiny part only. So if I draw a line from this point to this point, right? Let me draw it for you. If I draw a straight line between these points, okay, then this part is called as aperture. Okay, remember that. Okay, we'll go to the textbook very soon, and from the textbook it will be even better. Okay, now going on to the next part, which we have already covered, right? Reflection by spherical mirrors. What happens in spherical mirrors? This is the principle. What is this line called?
Principal axis.
Principal axis,
Principal axis.
right? And when we put an object along this principal axis, right, then we have the incident ray, right? This is the incident ray. When incident ray is parallel to principal axis in a which type of mirror is this?
Concave.
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 Concave. Come on, guys, don't make mistake in this one, right? And it is confusing, so you will need to read more and more, right? The many times you go through it, the basically this is remembering this definition is like remembering the tables. How did you remember the tables? By drilling, है ना? दिन में 5 बार 10 बार बोलते थे, 2-3 बार लिखते थे, तब जाकर के टेबल्स याद हुए थे, उसके बाद मैथ्स इजी लगा ना, है ना? बाकी जब पहली बार देखा था तो अरे ये कौन सा पहाड़ आ गया है, राइट? और हिंदी में उसे पहाड़ा ही बोलते हैं, राइट? So we have got a parallel ray, right? A light ray of incident parallel to principal axis. So this is a mirror. So it will come back, right? It will get reflected, and it crosses, or rather it meets at F. What is F? What is
Focal
F?
point.
Yes, very good. Focus, right? Very good. Principal focus, right? F. Okay. When it is a convex mirror, the incident ray will get reflected, right? So this is the reflected ray. But in case we want to have a image, we will have to extend this line. We will have to theoretically extend, है ना? ये हम imagine कर रहे हैं, right? This is our imagination. Okay, अगर ये incident line या incident ray यहाँ पे आया और यहाँ से reflect हो रहा है, it is if it is reflected here, and if we extrapolate it on the other side of the mirror, है ना? Then it will meet at principal focus, right? Yes, everyone clear on this one?
Yes, sir.
Yes, sir.
Very, very good. So passing through the focus after reflection goes parallel to the principal. In a concave mirror, a ray of light passing through the focus. If the ray is passing through the focus, then after reflection it will go parallel. Let me show you, right? See, this is the incident ray. If the incident ray is passing through the focus, then when it gets reflected, it will be parallel to principal axis. See, now this you have to remember, because then only you will be able to create the images, है ना? Right? Same way for in a convex mirror, a ray of light directed towards the focus after reflection goes parallel to the principal axis. So the incident ray will actually be going in this direction, है ना? See, the incident ray, now here it is imparting, or rather it is directly coming in contact of the convex mirror, right? So by the nature of the mirror, it should get reflected, but if you extrapolate this incident ray, it will come to f only, है ना? Right? And it gets reflected, and when it is reflected, it will become parallel to the principal axis. ये समझ में आ गया?
Yes, sir.
Very good, very good. Next one, in a convex mirror, ray of light directed towards the center of curvature, convex mirror, right, directed towards the center of curvature after reflection is reflected back along the same direction, right? ये actually first line की figure ये वाली है. This is for concave mirror. A ray of light passing through the center of curvature after reflection is reflected back along the same direction. Why is it happening? Why is it happening? Does anyone have any idea? Have you studied circles? Have you studied circles?
Yes, sir.
Right?
Yes, sir.
So when I talk about, sorry, when I talk about one particular concave mirror, है ना? I'm talking about concave mirror. Do I have format? Yes. So when I talk about the concave mirror, this is the concave mirror. Yeah, right? Correct?
Yes, sir. Yes, sir.
Very good. And this is the center, right? This is the center we have, right? So if the
Yes.
incident ray is passing through this, incident ray is passing through the center, right? Then we know from the properties of properties of circle in mathematics that this angle, right, this angle will always be of what? 90 degrees, correct? Yes. If, है ना?
Yes, sir.
Yes, sir.
तो आप सबको ये पता होना चाहिए, क्योंकि ये सर्कल में आपकी प्रॉपर्टीज में आता है, right? And if it is imparting at this point, then it will be reflected at the same angle back. ठीक है? Got it?
Yes.
So let's go back to that one. Yeah. Okay. Sorry. Where's my PowerPoint show? Hold on a second. There it is. Yeah. Okay. So it will get reflected back along the same direction, है ना? Right? See, the incident ray is in orange, red, orange line, and the reflected ray will go back along the same path, है ना, which is annotated by black arrow dotted line. ठीक है? Same way for a convex mirror. Now we know for a convex mirror, the center will be beyond this one, है ना, somewhere around here. So you have to think about this one, and the reflection will be in also the same direction, है ना? तो दोनों में थोड़ा थोड़ा डिफरेंस आया समझ में, कि पहले वाले में कहाँ पे हो रहा था, जब अगर, right, if, right, in this one it is the same. When the incident ray is passing through the f, the reflected ray will be parallel to principal axis, right? When the incident ray is parallel to principal axis, the reflected ray will diverge towards f, right? We have done this, correct? आपको पैरेलल उसकी सिमिलैरिटीज साथ में नोट करते रहना है कि दोनों की सिमिलैरिटीज कहाँ पे आ रही है ना? राइट? आर यू विथ मी? Three different types of rays and three different types of reflected rays, right? Now, in a concave or convex mirror, a ray of light directed obliquely at the pole. is reflected obliquely, making equal angles with the principal axis. Right? Look at this one, directly towards the pole. है ना? So whatever the angle of incident, the angle of reflection will be the same. So basically at the pole, the spherical mirror, it gets converted into what? When is the angle of incident and angle of reflection are same?
when it is formed on a flat plane.
Yes, if it is a plane mirror. So at pole, because pole is one tiny part of it, and we know that circle is nothing but tiny line segments connected with each other, है ना? Right? So at
Yes.
pole it becomes a plane mirror itself. We can say it that way, है ना? We can understand it that way. Okay, at pole it will be the same angle of incidence and angle of reflection will be the same. Okay, right everyone? Yes, any
Yes.
question?
Yes, sir.
Very good. Any questions up to this point? Now we will study the images formed by concave mirror, which are how and when we put different images or rather object at different distance. We are talking about concave mirror, right? This is the concave mirror, this is the principal axis, right? We have got principal axis and this is the object. Now from this object, if we put it at different places, way far from the very away from the concave mirror, then how the image will be formed? If we put it near to the principal center, right? Sorry, this point C, center of curvature, then where it will be? Then when we put it between C and F, how the image will be formed? When we put it between on F, how the image will be formed, that we are going to study. When the object is at infinity, that is infinity from where? From the concave mirror. The distance between object and the mirror is very big. Is formed at the focus. It is highly diminished, very small, right? The mirror image will be very small, real and inverted. The image will be real but it will be inverted. So if it is real, then we can get it on the screen. Yes, look at this one. This is the principal axis, the object is very far and these are the incident rays, है ना? From one from the top, one from the bottom. Okay, so when they get from very distance, they come parallel to the principal axis, and from when they come parallel to the principal axis, they get reflected and merge towards F, right? Principal focus. Okay, yes everyone, noted?
Yes, sir.
Very good. So when the object is very far in front of a concave mirror, right, the image will be where? Image will be at focus, very small, highly diminished is very small in simple terms. It will be real and it will be inverted. Okay, right? Got it everyone? It will be very small, very tiny speck
Yes.
will be seen, very tiny speck, है ना? When it is when the further the distance, the smaller the image. So you can think that when it is coming closer, slowly and slowly the image will get larger, है ना? Right? That we will see in the simulation. I'll show you the simulation also, right? When the object is beyond C, not at infinity, a measurable distance, a reasonable distance, है ना? When it is beyond C, the image is formed between C and F. It is diminished, real and inverted. Okay, let's see. This is the principal axis, right? It is beyond C. It is at a reasonable distance. Okay, so it will be the image formation will be between C and F. Okay, from the top there are two lines or rather two incident rays and the image form will be here, right, at this point. So it will be small, it will be small, it will be inverted and the image will be real. Okay, clear everyone?
Yes, sir.
Any questions up to this point? Do you have none?
No, sir.
Excellent, excellent. Right. So now the third one. First one was the distance between the object and the mirror is at infinity, very far. So the image form will be very small. Yeah, it will be very small. It will be where at the focus it will be inverted, right? When the distance between object and the mirror, right, so it is far from c, it is far from c, not at infinity but near, far from c, then the image will be between c and f, real and inverted. Okay, when the object is exactly at c, the image is also formed at c and it is same size as the object, real and inverted. Let's see, right, this is the object. So one line from the top and the another line also from here. Okay, right, yes, you see,
Yes.
and this is the reflected light. Now we know that when, this is why I told you that you need to pay attention, because when the incident ray is passing through focal length and falling on the on the mirror, right, then the reflected ray will be parallel to principal axis. Got it? अभी समझ में आया कि पहले क्यों वो रे वाला समझा, उसके बाद हमने ये स्टार्ट किया. Are you clear on this one now?
Yes.
So this is the place, it is right below C, right below the object, and it will be inverted. This is the image formation. The image formation is denoted by dotted lines, right? It will be same size as object, it will be real and it will be inverted. Okay, got it?
Yes, sir.
Very good, very good. Now what happens when it is between C and F? Right, it is between C and F, the image is formed beyond C, it is enlarged, real and inverted. Now if it is between C and F, right, this is the object, so this is the incident line, incident ray, it will get from reflected from the surface and it goes beyond C. The second ray, it passes through the F, but look at this one again, passing through the F, so it will be parallel to the principal axis and the image formation will be here. The image formation, the image formed will be large, enlarged, है ना, बड़ी हो गई है उसकी image. It will be real and it will be inverted. ठीक है? Yes, are you with me?
Yes, sir.
Okay, very good. Next is when the object is at F, right at the F, the image is formed at infinity, it is highly enlarged, real and inverted. When you are, this is, this seems to be an error, this arrow should, this object should be at F, है ना, or rather the F is here. Okay, see, this is directly the incident, look at the incident ray itself, right, from the aperture itself it is being reflected. Sorry, hold on a second, this one. Yeah, so the image will be formed at infinity. Why I haven't shown infinity here? Can we identify, can we quantify infinity? No. So this will keep on going, and when they merge together they will become what? Really large, very big image, right? It will be real and it will be inverted. When the object is between F and P, the image is formed behind the mirror, it is enlarged, virtual and erect. Okay, look at this one, it is F and it is between F and P, so the reflected ray should go in this direction, right, and we will have to, okay, so we will have to extrapolate it, right, and they will form, they will be formed, the objects, look at the size of the reflect sorry uh, uh, the image formed, है ना, it is enlarged. Look at these two rays, we have to extrapolate it, है ना, beyond the mirror, so it will be virtual. If it is virtual we cannot project it on a screen, correct? Yes or no?
Yes, sir.
Yes, sir.
Very good. So the reason that I'm trying to connect these dots from the very first lecture itself is The questions will be asked in this way, not straight simple question that explain the image formation by concave mirror. No, I'm not going to do that, right? Of course you will be writing such questions so that you have enough practice, but you have to think about scenarios, है ना? Practical based questions. Sorry. Right, so when I say that on a concave mirror, right, an image is observed which is virtual, then give me the position of object. So you will have to connect the dots backwards, है ना? थोड़ा पीछे जाना पड़ेगा, बैक इंटीग्रेशन बोलते हैं उसको, राइट? अभी इमेज इज फॉर्म बाय कॉन्वेक्स मिरर, वो बाद में देखेंगे. Let's go to the simulation that I wanted to show you. Terms to describe. Okay, right. Let's go back to the simulation. Where are we? Yeah, right. So again, going back to Amrita Labs, right? In a concave mirror, these are again very easy practical. I believe we have discussed about journals. You will be writing journals, है ना? Practicals आपको लिखने हैं journal में. आप सबके पास है journals? Do you all have it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good, good. So I will discuss with our parallel teacher Jyoti ma'am, and we will get cracking on the journal also, so that we don't have to worry about it in the last time, है ना? So this is a practical that we are supposed to do. If the situation permits, if the COVID situation dials down, and if we are able to come to go to school, then I would like you all to perform the experiment in actuality. For now, we will have to do with this simulation, right? So the same theory that we just discussed, right? Everything is mentioned here, real image and virtual image and everything, right? It is very understandably given in the black and white. Okay, this is the theory part. Now the procedure, that the procedure which you will be writing in the journal, right? This is the procedure that you will be writing in the journal, and then you will be observing. Now this kind of observation table you will make, and then you will have to note down your observations. Okay, but for simulation, this is the procedure. Select show labels, checkbox to view all labels in the simulation, show help, right? Object. So we'll go to the simulation just now, or rather, we should go for, no, they haven't kept the video in this one. Okay, let's go to simulation. It's taking time. I'll share this link with you all in the Google Classroom, and I want you all to perform this simulation today itself, है ना? तो ये पूरा अच्छे से याद रह जाएगा. Yeah, okay, right? To study reflection in concave mirror apparatus, a concave mirror and an object. Okay, let's see. So this is the object. Okay, this is the object. Now, can we move it? Hmm. See, I'm keeping it at infinity. Yes, we just discussed. Right, show rays. Right. So the incident ray from the object at a very far distance from C. This is the mirror. This mm dash, this distance mm dash is the aperture, है ना? So we when we talk about image formation, we talk about where the aperture is very less compared to the actual diameter of the mirror, है ना? Always remember that. Okay. Now when the object is at very far from the center, right, or when it is at infinity, this is us observation. Look at the incident rays. One is directly parallel to principal axis, one is passing through here. When it gets reflected, we get the image between C and F. This appears to be F, है ना? Right? And look at this one. This is the image, very tiny, inverted, and it will be real, right? Yes, are you with me? Hello everyone.
Yes,
Yes,
sir.
sir.
Yeah, I thought everyone went to sleep or what, right? So now we will bring the object close to C. Hana, look at this one. As I bring it closer, what happens? Look at the size of the image also. Keep an eye on. I'm finding it a bit difficult. I'm really sorry because with one hand it gets really tricky, right? Ah, yeah. See, as it is getting closer to C, it is still not very close to C. Look at the size of the image, right? It is increasing, right? When it is very close to C, right? When it is very close to C, look at the image formation. It is between C and F. It is between C and F. The image is virtual. Image is still diminished, right? Still it is small. Okay. When the object, when the object is exactly at C, sorry, अरे यार थोड़ा सा it's difficult. Hmm, right? Okay, look at this one. Almost same size, right? It's not exactly at that point, right? I'm finding it a bit difficult thanks to my broken hand. Yeah, okay. So when you try, you'll be able to do it, right? I hope you will be able to do it, and I hope you enjoy it, right? So when it is at exactly C, the image is also at C of the same size. It is virtual. Sorry, it is real and inverted. When the object is between C and F, see, the image is getting larger and larger. It is increasing in the size, but still it is a real image. It is inverted, है ना? When it is exactly on F, see, uh, sorry, you can't see the image formation also. The when it is exactly F, it will be at infinity, है ना? Because these two these two reflected rays, they have become almost parallel, and when they are almost parallel, they will keep going on and on. The distance is very far. That's when you will find the image, right? It will be highly enlarged, it will be virtual, sorry, real, and it will be inverted. Now when the object is between come on, अरे भाई हाथ. Mhm. Sorry, really sorry. I'm not able to do it. No, sorry, I'm not able to do it, but you can manage it, right? I hope you will be able to manage it. No, it's really difficult. Okay, so I'll be sharing this link. I'm going to share this link right now in the chat box also. Where's the chat box? Stop share. Yeah, to everyone. Let's do it. This is the link. You can copy paste it and save it later for later on. If you can't, that is also fine. We will. I will share it in the Google Classroom also for you. But I want you to perform this simulation today itself. Today itself, without fail. Right? I don't care if you don't have enough data. If you are going somewhere out with your family, please do it today. I'm requesting you, right? Please do it today. Unless you do this today, I'm telling you, if you come back to this simulation, if you read this particular chapter point of this chapter, just one day after, you'll find it difficult to identify and visualize the image formation. If you do it today, right? If you do it today itself and answer the questions, right? Let me show you. Let me show you again. Mm, yeah, okay. See, viva voce. If you answer these questions, right, today itself, I can assure you that you will be very good with this chapter, right? This particular topic, you are sorted, right? And if you are sorted in this period, this particular part of this chapter, minimum 5 marks, minimum 5 marks of your 10th board exam given. Now that is provided if the this Chinese virus permits us to take the exams next year also, right? But forget about the exams. This particular topic has practical implications in our life also. This is an extremely important chapter, right, in terms of learning science, in terms of visualizing and observing the things around us. When you see an object, when you see things around you, you should be able to see things in a different way now. When you see an image, you should, the thing that should come to you is what will be its aperture, what will be its center of focus. You have to start thinking that way. So again, I'm requesting you all to go to this particular page and answer these 5 questions. Very easy questions. Okay, these are very easy questions. You can do it on your own, and you will be able to do it. All right. And then there are some reference books, where reference materials where you can see image formation from concave mirror, right? Some more simulation and videos are also given a video to watch, right? This is very interesting video. You can see it again. Okay, everyone. Yes.
Yes.
Very good. Very good.
Yes, sir.
Okay. So, any questions up to this point?
No, sir.
None?
No, sir.
Wonderful. Wonderful. Okay. So, once you do that, once you have gone through this chapter in the textbook, let's talk about the textbook. Here we are, right? See, this is the table. Image formation by a concave mirror. Now, I want you to make this table in your notebook, cut it out, right? Make it like, make it wonderful, make it beautiful, right? Use different colors. Try to, make it in a A4 size paper, and put it on your wall. You should see this day in, day out. Okay, right? Look at this. This is very important table. A similar table will come for convex mirror also, right? We will do that, and that from that table only, I'm telling you, you will have 2 to 3 interesting questions, right? Yes. Okay. So this is what I want you to read all the way from 10.2 point, or basically 10.2 itself, right? Activity the 10.3 also you can do on your own. Representation of images formed by spherical mirrors using ray diagrams, right? This is just what we discussed, right? This is the same thing that we have discussed. You will have to draw these pictures on your own, and you will have to write the answers also. Okay, if we image formation by a concave mirror again, right? All this discuss, what we have discussed, right? And then we come to uses of concave mirrors. Very important part. Used in torches, searchlights, and vehicle headlights to get powerful parallel beams of light. They are often used as shaving mirrors to see large images of the face. The dentists use concave mirrors to see large images of teeth of patients. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Image formation by convex mirror, that we will see later on, but this is another important topic, uses of concave mirrors, right? Why? Now my question to you all, right? Mirrors are commonly used in torches, searchlights, and vehicle headlights to get powerful parallel beams of light. You know how the mirror works, right? You have seen the vehicle headlights of your scooter, of your Activa, or your car, right? I want you to study. Now this is practical aspect. I want you today, I want you all today to look into the headlights of your vehicle and see the position of the light, the bulb, the mirror, and why it will give you a very good focus. You have to think and answer to me, right? In the next session, not today. We will have another session today also, but that will come later on. Okay, that's it for the day, everyone. I'll see you after 1 hour. Bye bye, everyone. Take care.